Okay, today we are doing some review of what we've been doing in logs so far. I'm going to begin with some basic patterns. Do you get that this to the this equals that can be rewritten? Would you please rewrite that? That was the very first thing we did with logs was rewrites. Okay, so if you rewrote this correctly, you should have started by saying, well, it's not a log, so I'll make it a log. And then what base should I choose? E, because that's the base. And then I switch to the other side, and then I jump back here, and there we go. Log base E of 5 equals X. Why is that any better than the first one? Yes, it can be put in a calculator, and it's solved for X. The other one was solved for 5. You don't usually do that. All right, so let's go to the next one. I'm going to pause for a second. I'm having some sort of a riot here. All right, so back to, I'm a little distracted here, but I was giving you a chance to practice some log stuff, and I'm going to give you another one here. Log base, I don't know what it is, but you should, of 10 to the 10th. That one simplifies. If you know the pattern, you just should be like, oh, well, the answer is this. So some people are going to say the answer is 10 to the 10th, and some people are going to be right and say the answer is 10. Why do I know it's 10? Because what base is this? 10. And if this and this are the same, the answer is the exponent. Okay. Next one. Let's see if you recognize this pattern. 8 to the log base 8 of 8. This is kind of a bad example because people will say, oh, okay, so the answer is 8, and they'll think it's because these two were 8s. No, the answer is 8, but it's because that one's an 8. So let me give you another one that's like it. 8 to the log base 8 of 2 to the 5th. So what's the answer to that one? 2 to the 5th. All right, because if these two are the same, then that one's the answer. All right. Next, let's just jump into some of the more challenging ones that we've done. We did encourage you to remember how to write inverses. I want to give you a really simple one. Would you just try to remember how to write the inverse of that? There's a 3-step process. I've already done the first step, which is you change f of x into y. Do you remember how to do this? In case you've forgotten, maybe you can tell us how to start. Yep. So this is x equals 2 over y to the y minus 5. And I can't just stop there. What do I have to do now? Yes. Mr. G in the back, tell me how to take the next step. Yep. Why did you do that? All right. And another way to think of it is you wanted to get rid of the fraction there. And so now I've got no fractions anymore. Do I have to multiply it out? Yep, because I'm trying to get y alone. If I wanted to get x alone, I would have already been done. The red equation had x alone. I want to get y alone, so yeah, I have to multiply it all the way out. Yx minus 5x equals 2. Now, next step to get the y alone. Mr. JH, far wall. Trying to solve for what now? Be careful. Usually we solve for x, but in this case, so I would not want to get both the x's to the right though. So we want to get, we don't care about the x's so much. We care about the y's. Now you're right, we're going to do something with x. What do you think we should do? One step. Just tell me one step. You're not right. But thank you for trying. All right. This is what we're doing next. It's okay. This is what we're doing next. Why am I doing that? Because I'm trying to get the y alone. And it had a bunch of things next to it. I would think of it this way. That's what I'm trying to get alone. So I want to get rid of that part. That's what I'm doing right now is getting rid of that part. And then eventually, I'm going to want to get rid of that part. All right, so first, we add 5x to both sides. Yx equals x. So I'm going to put the 5x first. You could put the 2 first. It doesn't matter. They're just being added, and the commutative property says you can write 5x plus 2 or 2 plus 5x, either way. And next, I'm going to do what? Divide by what? X. That way, y is alone. Solved for y. That's my inverse. Now let's look back at it and talk about what inverses mean. Do you get, this one had a 2 divided by, and this one's got a, wait a minute, 2 divided by x minus 5. Let me make sure I didn't make a mistake in there somewhere. You got the same thing as I did? All right. This is why we don't just say, okay, well, it had a divide, so you have to do a multiply. I mean, we do have a multiply in here. And it had a minus 5, and so you have to, like, add 5. Well, we didn't. We had a minus 5. We changed that from a minus 5 to a plus 2. So you can't just look at the original and say, okay, you just do the opposite of everything in there. It's not quite that simple. All right. So when it's all said and done, that's an inverse. Do you get that if I knew the domain and range of this guy, which I do, I would know the domain and range of that guy instantly? Do you remember how that worked? Yep. Ms. KU. What do you have to add to the conversation?
If you were to like separate it out and have the x under the 5, x under the 2.
Okay, yes, I can do that. Y equals, hold on, 5x over x plus 2 over x. What that does is split them both into separate things. I see what you're saying. Then it's y equals 5 plus 2 over x. And that's a cleaner representation of this original one. I see what you're saying.
Or you could just not originally multiply out.
That's okay. Could have divided by x right away. All right, so what we've come to is there were many ways to solve this problem, but the answers would boil down to 2 things. Either the red one that I had or this blue one I just put a square around. But either way, let's go back to your domain and range thing because that's important. Go back to the original problem, figure out its domain and its range. Well, domains are easy. They're all about the base. It's what could make this thing equal 0, or no, not what makes it equal 0. What makes it crash? So everything works except what? 5. So everything except 5. So here's a 5. It's everything except that. That's the number line way to write it. We could have used intervals and said negative infinity to 5, and then 5 to infinity, and the u between them. The range. Well, the range, if this is a fraction function, do you remember it's kind of something like that? And it all depends on where its horizontal asymptote is. Do you remember that Bob tells us the horizontal asymptotes? All right, so is this bigger on bottom, bigger on top, or same on both? This function, is it bigger on bottom, bigger on top, or same on both? Bigger on the bottom. And let's not have any bad pickup lines today. It is bigger on the bottom. And so now I can say, oh, it's a Bob. Therefore, it's y equals whatever's on the outside of the fraction. Is there anything on the outside of the fraction? No, so I can say y equals 0. So that, what does that mean? That means its asymptote is right here. So its range is everything except 0. Okay, there's my domain and range of the original. Does that ring a bell? Do you remember how to do that? For the range, it was definitely the harder part, but all I needed to do for the range was to figure out that it goes everywhere except here when you're talking up, down. It stops at that asymptote line. Okay, so then why was I doing that? Because now I want the domain and range of this guy. So what you do is you say, okay, Mr. Server, I could redraw this picture. No, you shouldn't. You should keep it simple. The domain and range of this guy are just a reversal. The domain from the original one was everything except 5. So that's the range of this one. Everything works except 5. I know some of you are going to say, wait a minute, Mr. Server, you can't have 2 in this equation. This is about the y's. The range of this is about the y values. Okay? Everything, it can be everything except it can't be 5. Think about it. Y equals 5 plus something. It can't be 5 ever. It'll have to be more than 5 or less than 5, but it can't be 5. Why? The range? Okay. But you don't have to think it out that much. All you have to do is say, well, the original domain was this, so that's its range. The original range was this, so that's its what? Domain. So the domain must be everything except 0. And 2. Why? Do you get why I can't have 2 in this function for x? Oh, wait. No, I'm wrong. I'm wrong. I can trust the original. Yeah. I tried to do it again. Even though I knew I wasn't supposed to do that, I tried to look at this and say, what can't that be? And somehow I got it in my head, it can't be a 2. No, it just can't be a 0. I can trust that the original domain and range can be reversed. Does that make sense to you? Everybody wants to take their new function and find its domain and range. Don't. Stick with the original domain and range reversed. All right, so then let's make this a little more pre-calcy. That was actually something you did in honors higher algebra. You learned how to do inverses back then. Now, what if you have to do an inverse of something like this? Log base 5 of x to the 1/2. Would you please, I've already done the first step, made the f of x equal to y. See if you can do a inverse on that. Then I would like to know the range of the inverse. Oh, what the heck. I'll just ask for the domain and the range of the inverse. So find the inverse and find the domain and range of the inverse. Don't fall into the trap that I just showed you. I'll pause for a second while you try that one. All right, so I hope that to the power of 1/2 didn't bother you too much. If it did, you could have put the power of 1/2 down here in front if you wanted to. Do you get you could have? Okay. And if you're trying to solve for x, no, yeah, x. Yeah, wait, first I got to switch. Sorry. First I got to switch my x and y around. Okay, so this becomes x and this becomes y. Now I'm going to solve for y. Okay. So do you get, I can just do a rewrite at this point, but there was one kid who did it a different way last hour I kind of liked. I just want to show you. This 1/2 can go down in front if you want to. Do you get that it can go there if you want to? Then do you get to get rid of it? You could multiply both sides by 2. Would that be agreed? Okay, so 2x equals log 5y. And then you do your rewrite, and it comes out quicker. 5 to the 2x equals y. I like that way. But here's the way I bet most of you probably did it, and I'll just show you. You certainly can do it the, quote, normal way, too, and it'll work fine. If I leave it alone, and then I just do my rewrite right off of that, I'd say 5 to the y equals x to the 1/2. And again, what are we trying to get alone, y or x? Trying to get y alone. Oh, wait, my x and y got to be reversed. I erased everything. This has got to be a y, and this has got to be an x. So this has got to be an x, and this has got to be a y. Okay, so now y is almost alone. Now you can fix it by squaring both sides. And this is a perfectly good way to do it, too. But either way, 5 to the 2x equals y. You might say, how did that become 2x? Squaring it like this, see? All right, 5 to the 2x is your answer. Raise your hand if you had that one right. Okay, good. Then, what's the domain and range? I would go back to the original and say, what was the domain and range of the original? Well, the original, get all this stuff out of here again, is a log. I know what they generally look like. I'm going to make a little picture of it because my domain and range will come out faster that way. I know it's a log. Now, granted, it's got that squared on it, which couldn't that just come down here and be a 1/2 in front and be like a stretch factor on it? Yep. And it's really not going to change its domain and range because if I stretch this a little bit, it's still going to be basically in the same spot. So maybe it's a 1/2 as tall now, so maybe it's a little lower. But either way, the domain on this is from 0 to infinity. Raise your hand if you got the domain of the original right. Okay, good. And the range of the original is from how low to how high? Negative infinity to positive infinity. That's the domain and range of the original. So the domain and range of the inverse are reversed. The domain of this is like the range of the original, negative infinity to positive infinity. And the range is the domain of the original, 0 to infinity. And just to clarify, they all have parentheses because it can't touch 0 because the logs can't have their x be 0. And that's because the argument here is not allowed to be 0. Okay. So now we did we found an inverse of something complicated, and then we found its domain and range by looking at the domain and range of the original one. Next topic. We have done a bunch of U substitutions. Do you feel good about the U substitutions where they become quadratics, or do you want to practice one of those? All right, so here's one. Log x squared plus 3 log x equals 4. Do a U substitution on that one. You don't have to. If you want to factor it using the log x, some of the more advanced students actually do that, and it's fine. But U substitutions make it a lot easier. Rise to it then. All right, so you got to give yourself permission to make this swap by saying, let U equal log x. How many of you actually wrote that? I know some of you are trying to take shortcuts because you think, oh, I'll remember that in the test. Don't remember that in the test, I can't give you full credit. This is what allows you to make the swap. Now, that's a U and that's a U. So it's U squared plus 3U, and then I'm really smart. I'm moving the 4 to the other side. Minus 4 equals 0, all in one step. Why? Because you have to set it equal to 0 to factor it. Then I factor it, and I get x minus 1 and x plus 4. And so the answer is x equals 1, x equals negative 4. But if I stop right there, I would be missing the whole point. The whole point of the problem was to find what log x would be. So I've got to figure out, or actually I do want to know what x is, but I should have done a U substitution, not an x substitution. That's one of the things that's a little messed up here. These should all be U's. And then I should notice if you see a U in your answer, you can go, oh, wait, I'm not done. U's are used for this. So I'm going to go back up and do the substitution back again. If U is this, then I can replace stuff that says U with log x. Log x equals 1. Log x equals negative 4. Final answer, base 10. Base 10. 10 to the 1 equals x. And 10 to the negative 4th equals x. Now, don't let 10 to the negative 4th freak you out. If you just think of that as 1 times 10 to the negative 4th, do you get it's just scientific notation? 0.0001. And this one's 10. 10 and 0.001. Some people look at this and think, oh, it's a negative number, so it's extraneous. No, it's not a negative number. That's a really small number. And if you actually plug them in, they actually work. I did check that quick because I wanted to make sure that I wasn't making something that didn't actually work. And it works. I'll show you the 10 really quick because that's super easy to show you. If I put a 10 here and a 10 here, do you get, since the bases are 10, that this becomes a 1, and that just becomes a 1, and 1 squared plus 3 times 1 is 4. Okay, cool. Now, next topic is, yep, the answers were that, 10 and 0.0001, 10 to the negative 4th. 10 to the 1 and 10 to the negative 4th. Nope, you got to move the decimal on the 1 4 spots to the left. Okay. Yep, the decimal's after the 1, 1.0 times 10 to the negative fourth. So then you move the decimal 4 spots to the left. All right, so now we got to do one where we have just complicated, like nested logs, nested in other logs. There. Now, do you get, if I figure out this whole thing and it turns out to be 16, then it's just log base 4 of 16, and so the answer is a simple number. Okay, but I don't know what that big red thing is. It's the argument. That big red thing is the argument of that other log. Log base 4 of that. Yes? Yes, me. And if I go deeper, I realize I have to figure out this so that I know what the argument of the second log is. So everybody start in the green area, the deepest part. And then use my rules I've told you about if they don't show the base, then you need to write what base it is. And you'll notice a pattern. When it's all done, if you get it, you'll be like, oh, I see. The answer is just 1/3 or something like that. The answer does come out to just a number. You pause for a second while you give this a shot. Again, start with the green one. Once you got the green one, it flows pretty quick from there. Okay, you didn't get it by now? Something wasn't clicking for you. So, here we go. If I say this is log base E, I hope that isn't a shocker to anybody. ln log base E, right? But then do you notice that this E and this E can get along and that the answer is sort of like going to be 5, except what about that 2 that's out in front? Oh, just put it up as an exponent right there. Good. So then it's really, since this and this are the same, the answer is 5 squared, which is 25. So the whole big green part of the problem is 25. Then we know it's log base 5 of 25. And that's just a 5 squared. Yeah. So that means this whole thing is just a what? The 2. The red part, the part that's got a big circle around it and is in red, comes out to 2. So if you left it this way, you missed the last little piece that could finish it off. Did you get how this part here came out to 25? Did that part make sense to you? Then I'm going to rewrite it. Log base 5 of 25. Do you get how that's really going to equal 2?
Oh, okay, I left the E.
All right, so then next step, this is your final answer unless you're smarter than that. Can you replace that 2 with a 4 to the something? 4 to the 1/2, because 4 to the 1/2 is 2. And therefore, the 2 4s match up, and therefore the answer is 1/2. How many you got there before I did? 3/4 of you. Good job. Yes, questions? Yes. Yep. All right, moving on. The last thing I have for you is just a quick demonstration on how important logs are when it comes to finance. That one's one of my math behind it, and I don't usually record those. So that's all I have for the lesson for today. We'll talk more about half-life in tomorrow's lesson.